Hey y'all, I'm Angie. Welcome to my channel where I do stuff. If you're new here, thank you for joining me, and if you're a returning subscriber, thanks for coming back. In today's video, we're going to be looking at some of my recent New Mexico rockhounding finds, but we're going to be looking at them through a microscope. Everything you need to know about today's video, my socials, and the equipment used in today's video will be in the description box below. So let's get started.
First up, we have gypsum, and this is very green in person, but as you can see under the microscope, it looks very gray and sort of clear. I love how reflective the different surfaces are, the different facets. I think it's really cool how you can see the little soil particles from the red dirt. And then the second part of this piece is the quartz. And if you saw my last video, then you saw a little bit better of a close-up of this. I mean, maybe not as good as a microscope, but still pretty good. These are very delicate little crystals, so I have to be very careful with it. But it's a really, really unique piece. This is calcite silicon fibers. This came from a road cut near the Guadalupe Mountains. Silicon fibers are minerals that are a secondary mineral rather than the original rock. So they commonly form along fault surfaces in areas where the rocks slowly creep past each other along a fault instead of sliding suddenly. And in this case, the fibers that are left behind are made up of calcite and were stuck on the host rock. Next up, we have siltstone ripples. I don't know how this was formed. I'm not gonna lie. It looks to me like it was just the fossilized mud at the bottom of deposition, at the bottom of like a waterway. I don't know. I'm purely guessing, and it came from the same area of the road cut as the previous one. Here we have unidentified organic impressions. That's the only thing I know how to call it. At first, and this came from the same road cut as well. At first I got excited because I thought they were insects, and then I noticed that if those were legs, there were way too many of them. So I started thinking logically about it and was like, well, they could be seeds that had like puffball kind of stuff on it to distribute it in the wind. I have no idea. But they embedded into the mud and then decayed away, leaving these hollow impressions in the rock. Interestingly, the other day, just a couple days ago, I saw an article where they found the first ever flower encased in amber. And it wasn't on this continent, but I was looking at that going, you know, that looks incredibly similar to the impressions that I found in this particular piece of rock. And I have no idea if that's what it is. I also have no idea if they're even remotely the same size, because I was not given any sort of scale for reference in the other picture in the article. So I'm not entirely sure. If you have any idea what these could be, please let me know, because I think they're incredibly cool. I just don't know what it is. If you've got any guesses, drop it in the comments below. Next up, we have quartz. And I love this particular specimen because it's very shiny, and depending on the angle, you can see all the way through it. Sometimes it looks a little cloudy. You can see the cleavage in it. You can see the layers, and it just sparkles. And also, like in this picture, you can see that the rainbows pop out in certain angles. And one thing that I thought was really cool about this specimen in particular was that in certain layers of this mineral, you can see where the red soil is incorporated in it. In fact, there's even one entire streak, one entire layer, it makes a big stripe through it that's red. And I just think it looks really cool, really unique. And here it doesn't look as pronounced, but when you're actually holding it in your hand, it's pretty cool looking. So pretty.
If you're enjoying today's video, or if you like the concept, make sure you give it a thumbs up, because it really does help my channel more than you know, and it lets me know how I'm doing.
Next up, we have a rhomboid calcite piece. This is really just a piece of, it's not really transparent, but it's in the shape of a rhombus. It's got rhombohedral cleavage. Normally this piece would have like double refraction and you could see through it. It's just not that clear, and it's also been tumbled a whole lot, so you can't see through it the same. And apparently I didn't clean it as well as I thought I did. This next specimen is druzy quartz, and I'm sure every mineral lover has seen this before at some point. This refers to a layer of minute quartz crystals that are crystallized on the surface of a quartz-based mineral. And so I found these all mixed in with Pecos Valley Diamonds, and this piece of druzy was specifically stuck to dolomite. There's a lot of that all over the Pecos Valley Diamond area. And I haven't just seen a whole lot of druzy, so when I did see this, I had to pick it up. Next up, we have a Pecos Valley Diamond that is double terminated. This is a piece of quartz, very small crystal, as you can see. And it's sort of an ombre color where one end is a very coral, peachy kind of color, and it slowly transitions into sort of a cloudy clear. Here we have another double terminated Pecos Valley Diamond, but this one has an extra termination sticking out on the side. And this is a pretty common thing for the crystals in this area. I read a scientific paper about the different shapes and colors and the different areas that these crystals can be found. It was really interesting, and I will link it down in the description box below if you're interested in reading it or just looking at the cool little pictures that go along with it. Some of those diagrams explain a lot about these crystal formations if you're interested. Next up, we have another Pecos Valley Diamond. This is also a double terminated quartz crystal, and it's just a very clean white color. What I noticed was it was shiny just after being washed, and that the facets are very sharp, so it hasn't had a lot of weathering and it hasn't been tumbled around a lot. So I thought that would be interesting to look at under a microscope, because so many of the other ones show a lot of wear. Next in line is a really cool piece of limestone that's either stromatolitic or oncolytic, I'm not sure. But it has calcite crystals inside. And it really struck me because it was shining when I stepped over it. So I had to pick it up because it was shiny and I'm like a crow, I guess. Stromatolites become a layered deposit of limestone, and it's a blue-green algae. They're one-celled organisms, such as cyanobacteria. The main difference between stromatolites and oncolites, which is the other possible thing, is that stromatolites have a tendency to grow in like columns, and oncolites have a tendency to grow kind of in spherical type structures. And they usually form around something, almost like a pearl, I guess, because they kind of form around like a particle of sand or like a piece of shell or something like that. Oncolites are also indicators of warm waters, and I just don't know what was going on in this area at the time. This next piece is a similar structure. It was found in the exact same location. It just doesn't have any calcite crystals in it. I don't know that much about the location where these were found. I am an absolute idiot when it comes to looking at geological maps and understanding the layers and all of that. It's the one thing that makes identification really hard sometimes. And so I always have to get help, and I feel bad bugging other people about it. So that is one benefit to having a YouTube channel is I know that a lot of y'all are much smarter when it comes to using geological maps and reference materials like that. So if any of y'all think that you might be able to help me out, please send me an email or drop a comment below. Thank you.
Well, y'all, that's all I got for you today. Thank you so much for watching. I really hope you enjoyed today's video. And if you did, then I really hope you'll consider subscribing because I would love to see you back here next week when I do more stuff. Bye.